All right, today we're doing lesson 9.6, which is solve systems of equations by graphing. So we're going to take what we talked about yesterday with graphing using slope-intercept form, and then we're going to use that today to solve. Now, the difference today is every problem you're solving, you're putting two graphs or two equations on the same graph. Okay? Yes? Is everybody with me? All right, so first thing I'm going to show you is how do we know what our answer looks like based off the graph. So I'm going to give you just a little chart to kind of help you. You don't have to, yours doesn't have to be quite, yours doesn't have to be this big on your paper, okay? Just however much room you need. Okay, so there's three different types. If I can spell. There's three different types of graphs that you could get, all right? So there's intersecting lines, there's parallel lines, and then there's the same line, okay? Now, that last one, does it look like there's two lines graphed?
No.
No, but if you have the same equation, isn't that going to give you the exact same line? Someone say yes.
Yes.
Okay, thank you. Okay, like if it says graph y equals 3x plus 2, and the other equation also says graph y equals 3x plus 2, they're going to look like the exact same line. Okay, so we have intersecting lines, parallel lines, and then the same line. All right, now there's three different answer choices. Depends on which graph you get. There is no solution, infinitely many solutions, and one solution. Does anyone think they could tell me any of the three by looking at the graph? One solution, no solution, or infinitely many? Vic?
The no solution is the same line.
Why would you think that?
Or never mind, parallel line.
Yes, because they never do what?
Cross.
They never cross or touch. So, if the two lines never cross or touch, that would be no solution. Does anyone think they could tell me which one would be one solution?
Same line. No.
The one line.
Intersecting.
Same line.
Which one do we think? One solution.
Same line.
So think about this. If parallel lines never cross or touch at any point, it's no solution. I'm trying to figure out which one has just one solution.
Intersecting.
The intersecting lines. Why?
Because they have one intersect.
Because they intersect at how many points? One. Okay, can anyone tell me why the last one would be infinitely many solutions?
Because one line.
How many times do these cross or touch?
None. What two?
How many times?
None.
None. The two lines are right on top of each other.
We're looking at the same line?
This right here,
Oh, I was looking at that one.
I'm talking about infinitely many. The one that looks like only one line. But we graphed two things, they went right on top of each other. So how many points do those touch at the same?
1, 2.
Oh.
Say it, Carson.
All.
All of them, right? Every single point on this line and every single point on the second line on top of it, they all intersect at the same spot. So that's why it's infinitely many. Okay? The easy two to remember are one solution and no solution. Because one solution, you're going to see the one place they intersect. No solution, they're going to be parallel. All right? They'll never cross or touch. Infinitely many would be the same line. Okay?
Can there be more than two lines on there?
Do what?
Can there be like other lines on there?
No, not on today's. We're only doing two equations. Okay? All right. Any questions on that? Okay. first thing I'm going to do is I'm going to give you a few graphs. You're going to tell me just what you think the answer is going to be. Okay? I think how I want to do this. It's up to you. I'm sorry.
On yesterday's homework, were we supposed to write a graph? For the graph one?
Oh, no.
Okay.
Oh, you didn't have to.
Infinite solution. Big dogs.
Okay. All right. If it gave you this graph and it gave you the two equations, y is equal to x and negative x plus y is equal to 0, all right, and asked you to just state one solution, infinitely many, or no solution, what would you choose?
Infinite many.
How do you know that?
There's only one line and both on top of each other.
Good.
So is there even like a point to look at the right side? Or it has negative x plus y?
This?
0? Yeah. In the future it will be?
When you have to graph on your own, yes. Because there's a couple problems where it just gives you the graph. You can look at the graph and tell, okay? But when you have to graph them on your own, that's why they give you those, okay? All right. Bless you.
One solution.
Okay. All right, what if it gave you these two equations with this graph? Y is equal to x plus 2, y is equal to negative half x plus 2.
Intersecting lines, right?
Okay?
One solution.
Intersecting lines, how many solutions will we choose?
One.
1. Now, if it is one solution, you have to state what the solution is. Does anyone think they know what the solution is?
Mm,
Well, how do you know it's one solution?
because of my cross one.
Because they only do what?
Cross one.
So where do you think the solution would be found?
On like one, two.
Where they do what?
Cross.
Okay? Where do those 2 points cross?
Two. Falls into
But we listed as an ordered pair. What would the ordered pair be?
2, 0.
Not 2, 0,
0, 2.
0, 2. Okay? So, when it's one solution, you have to state what the solution is. All right? Does everybody understand that? So, you're just going to look, where do they cross? What's that ordered pair? Okay? Do I even need to go over parallel lines right now?
No.
Because we're going to know what it is. Cool. Okay, let's graph some on our own. Oh yeah.
How many questions do we have then?
5.
Man, can you just like open that other one? I can just do this at
But it's not
Let's
I'm talking.
let's get through today's lesson first. Okay. All right. It's going to give you a system of equations, right? These two equations right here. And it's going to tell you to graph the system and then write its solution. You can choose no solution or infinitely many. Okay? So, the first thing we're going to do is graph that top equation. Can anyone tell me how I would graph the top equation?
Here's the term. and then some
What's the
back
first
to-
point I would put on the graph?
Oh,
I'm talking about this one.
there you go.
Good. Always start with your y-intercept is -2, and then use the what?
X. No.
Come on, y'all. We just did this yesterday. What do you use to find your next point?
Slope.
Slope. Thank you, Jake. What's my slope in that top equation?
3x. 1x.
Okay, it can never be x. It's the number in front of x.
1.
Okay, so 1 or just 1 over 1. So from the point I just did, how am I going to move?
Go down. Up 1.
Up 1,
Right 1.
right 1. If you need another point, up 1, right 1. Okay, and we're going to draw a line through those points. Okay, then I'm going to do the same thing, but now I'm graphing the second equation.
So up 2.
Start with the, I'm going to switch colors. Start with the y-intercept, which is +2. What's my slope?
3 over 1.
3 or 3 over 1. So what direction am I moving?
Up
1, 2, 3, right 1.
I'm gonna do it twice.
Sorry, that was kind of a bad line. Really should have been like, I want to erase that and fix it. Now, you shouldn't have a problem when you're doing this on Alex because your lines will definitely be straight. But what is my answer here? One solution.
Intersect new line.
All right. Now, can anyone tell me what my one solution is? How many did I go over? 1, 2, 3, down. 1, 2, 3, 4,
-3.
5.
Wait.
-3,
-5.
-5. Okay?
Is that all we have to do then?
Yep. Okay. Now, can anyone tell me what I should do before I even start graphing?
You
Oh, no,
want to
it's-
switch them around, right?
Switch what around?
You make 0 equal, or no, 1.
That's not the problem. Is
You
Find out what
switch
x
around.
is. I mean, find the slope then.
Subtract it by 3x, right?
okay, so what are you doing when you do that? You're moving it into what form? We did it yesterday.
Slope.
Yes, slope-intercept form, right? Is my bottom equation in slope-intercept form?
Yes. No.
No. So like Brody said, we're going to move it into that form. So Brody said subtract 3x from both sides. Okay, what does that leave you with?
Negative 4.
-4.
-4y equal to what?
-3x.
Okay, what would be my last step?
Divide by 4.
By what?
By
-4. Okay, so -4 over -4 cancels. I get y is equal to what? Can I simplify -3 over -4?
No,
Just be -3 over 4.
it would just be 3/4.
Why would it be just 3/4, Cash?
They're both negatives.
Because negative divided by negative is a positive. Good. Okay, what do you notice about this and this?
It's the same.
They're exactly the same. Do you already know what the answer is going to be?
No.
Yeah, we do. If you get that exact same equation, what's that going to happen when you graph both of
They're
them?
gonna be equal, or the,
They're gonna be the same.
Yeah, they're going to give you the same line, right? So we need to graph one of them to show that. What's my y-intercept? 0. From there, use the slope. What direction do I move?
3
Up 1, 2, 3 over 4. Okay, I don't need to graph the second one because it's going to give me the exact same graph, correct?
So it'd be
So my answer is what?
same line.
Infinitely many solutions, okay? Now, what that means is any ordered pair on this line is a solution to this equation, okay? So 0, 0 would work, 4, 3 would work. All of those solutions on that line work for the equation. Do we understand? Okay, all right, last one. Shocker. That's not what I want. Okay, first thing I want you to look at. Are both of these equations already in slope-intercept form? Yes. So do I need to do anything with them? No. I can go straight to my graph. All right? Who can graph the top one for me?
Go up, no, down 3.
Okay, go down 3 because my y-intercept is 3. Okay, then use the slope, Vic. What would I do?
Go over 1.
Over 1,
Up 1. Go
up 1, and right 2. Okay, somebody else do the second one for me. Come on. Victor's the only one in here that knows how to graph these.
Go down 2,
Thank you. Okay, then use your slope.
up 1, to right 2.
Okay, again, I know my graph's a little shaky, but we know our answer is going to be what? Now, can you tell that it's going to be no solution by looking at the graph?
Yeah.
What part of, or sorry, by looking at the equation?
Yeah.
What part of the equation would tell you that?
So the line
Negative 2 and negative 3. Oh wait, no, it would be the halves.
Yes, it would be the half, right? Anytime you have the exact same slope, that means your lines are never going to cross, okay? Same slope, but they have different y-intercepts. So here's the deal. You can tell just by looking at the equation before you even graph what your answer is going to be, right? Now, you still have to graph, but we should always be able to tell, okay? Any questions?